Okay, we're live.
Hey, good morning, everyone. Welcome to another edition of Wikimedia Tech Talks. Today, we are having Alexandros Kosiaris, who is a senior operations engineer on the SRE team at the Wikimedia Foundation. He's going to be telling us about the new deployment pipeline, which I believe is already being used by a few services. He's going to tell us a little bit more about that. And if you have any questions, please direct them to me on the IRC channel Wikimedia office. With that, Alex, you can go. Let me stop this.
Hello, everyone. As Subbu already said, I'm Alexandros.
You need to present the slides. You need to present it.
And I'll be presenting you. Yes, doing it. So yes, doing it right now. We'll be presenting today let me change this to put it in my other window, workspace, and present and full screen. Wait, let me get my presenter notes. Full screen. Good to go?
Looks good.
Great. So the topic of this talk is the deployment pipeline, 3,000 meters and 48 meters of overview, which is a pun on the 10K feet usual stuff that you hear about. As Subbu already mentioned, direct questions to him. Note that the slides are numbered, so if you want to refer to a very specific slide, feel free to. It will make it easier at the end of the talk to just skip down to the specific slide in case you have something to ask about that one slide. Let me start by giving you a problem statement. And some people might have seen some of these slides, as the specific problem statement has been reiterated in the past. So let's start very, very generically on this one without having anything to do with a pipeline. And the question that we can ask ourselves is, how does a user deploy or run code? And in the very general case, it just needs an execution environment. And here are 4 examples of execution environments. So to give you quickly what those are, the top left is ENIAC. If any of you recognize the punch card, congrats. The others are MS-DOS. There is a POSIX/Unix variant, which is a SunOS Solaris 10 on the top right hand side, and there is of course Windows. You can think that's a screenshot from Windows 95 or Windows 98, something of the two, on the bottom right side. So what does all of these environments have in common? They're all execution environments, and the end user decides what they want to execute, whether that is double clicking, or there is just typing a command at the shell, or God forbid, punching holes in a key card. At the end of the day, it's just that they just define what they want to execute. And while that's something common to all 4 of those execution environments, there is something that they don't have in common, and that's aside from all the other stuff like easiness of running or deploying or whatever. And it is the fact that if we split them to the left-hand side and the right-hand side, and no, that's not a political statement, by the way, they're just arranged like that. The left-hand side, it's actually without a scheduler. On ENIAC, there would be no scheduler. At the moment that you put the card in there, it would run your program. So what actually implemented the scheduler was a person. And at the beginning, stories that have not been published tell us that people that had, connections to the specific scheduler person would preempt others and, would cheat their spots on the queue. There was always a big queue for the ENIAC machines. And of course, that spawned an entire process and people and having to care about it and a lot of strict measures so that, nobody would preempt others and all. And quite of a big mess. Then, microcomputers came along and MS-DOS. It's also without a scheduler. That means there is only one single process ever running. There are tricks to simulate multiprocess. That's what viruses did back then. But the right-hand side actually has a scheduler. That means multiprocess, multi-user, multi-everything. And in all of these environments, whether they are left-hand side or right-hand side, we can ask a question. And while I ask that you keep the scheduler idea in mind, because we're going to be talking about it later on all of those environments, how many things does the user have to care about? And the answer is they only had to care about, at least in the general case, how to execute the software. Whether it was double-clicking or feeding a card, that's about it. And they did not have to care about CPU placement, memory placement, network capacity, disk throughput, disk space, none of all of these. And yes, there are cases where you have to go around and care that you have an SSD and not a disk, a hard disk, not spinning Rust. There are cases where you might go around and care about pinning a specific software to a very specific CPU, but this is not the generic case that we are actually talking about here. And now that we painted this rosy picture, let's contrast this to how we currently deploy and execute code in WMF, at least currently in the majority of cases, because as you will see at the end, there are some cases that are not so bad anymore. So note, by the way, that in the question we already no longer say developer, we no longer say user, we say developer. So we're already talking about a person that is more technically inclined. And this is a very, very ugly slide. It's ugly on purpose because the situation is ugly. So the developer will go around and write the code. Then they will go and test it locally, if they test it locally. They'll push to get it. Then they will wait for CI. And they will also wait for code review by other people. If they don't go around and, try to merge themselves, at some point they will get the code merged. And all up to now, it's more or less fine. And here starts the ugly part. They'll have to go then and build a deploy repo manually. A deploy repo is something that generally gets created by going around and installing the various dependencies. So you're going around and running composer install, pip install, npm install, whatever of these things is actually required. And after that, you try somehow to deploy that repo to production. And at best, I'm assuming that you actually tried and you know what you're doing. The tooling does support it, but you have to go around and define everything yourself. You're going to be doing it with a blue-green method. That is, blue-green stands for a method where you go around and deploy parts of the infrastructure slowly, one by one, testing them, and then killing the previous one and putting the new instance of your code into production. And after you've done that, it might error out, and you'll probably have to figure out why, I don't know, machine does not work. And why that might be true, CPU contention, because in the current case, most services are collocated, so something else might be eating your CPU, or you might end up deploying something that is CPU and starves others. Well, same goes for memory. It might very well have been that the machine has run out of disk space in some of the partitions that they have. Why on earth do you even care when you deploy code what the partitions are and what disk space do the machines have and all that anyway? And well, the machine might actually be dead. That's something that has happened, and it's still happening at times with MediaWiki. One of the MediaWiki servers dies, and then the train coincides with SRE trying to pull it out of rotation, and then SCOP kind of stalls and all. And it even puts up a very interesting question. When the machine is back on, what version of the code is it running? Because if it was out and, SCOP skipped it, what's going on now? We do have tooling and efforts to combat those problems, but still they do creep their ugly head every now and then. And of course, a perennial question, what I deployed is actually what I was testing, is the thing that I know that I tested the same thing that I deployed, because there is the possibility that other changes, piled on top of it, and it's no longer what I thought I had. So all of those things that I've painted in red, all things that we don't really want to expose people to it. And while we have all of those red things, we also don't really have elasticity. That is, we cannot react to increased demand, which is something that has happened quite a few in the past, especially when some GLAM user, in our specific examples, uploads tons of videos to Commons, and then all the recoding and re-encoding takes place. And yeah, video scalers tend to be fighting with all of that load when we do not have the capacity to, add more workers to help with that, temporarily at least, to help with all of that load. And at the same point in time, that we cannot run multiple versions of code simultaneously in order to test something. We cannot really do canaries nicely. We have collocated services where they share dependencies, and that's, for example, all of the Node.js services that are residing, for example, on our SAB clusters. So there we have the usual case where some service wants to upgrade to, I don't know, Node.js 10 and take advantage of all the cool new stuff, but some other straggler fights to get upgraded to Node 10. And while it does have the nice consequence that, the entire group moves along as a herd, it does overall slow down the speed of some people in order to increase the speed of some other people. It has its pros and cons. Overall, it does cause friction. There is also no hardware fault tolerance. Bug dies. We lost that capacity. The deploy repo, nobody really uses it for any environment. It's just that the deploy repo. But we could do that. We could go around and take that deploy repo, that artifact that we talked about, and use it to deploy, to develop stuff locally. And let's not even talk about the first deployment. When you put the service in production for the very, very first time, and you have to find our hardware, find out how to create the deploy repo, find out how to configure your deployment tool, which is CAP in our case for most of the tools. There is, of course, beta cluster as well that you might have to go through, although there is a code stewardship request for it. I'm not even sure about the future of the beta cluster currently. And all of this means you have to talk to multiple teams. You have to talk to the services team probably, you have to talk to the release engineering team for sure, and the SRE team for sure. That is gonna take time. So how about we go around and abstract some of these problems away? And here's some ideas of how we went around about abstracting the problems away. As you remember, a few slides ago, I talked about the scheduler. We could have a scheduler, an automated program, and not a human being, because that's what we're currently at. Usually, I am your ENIAC scheduler. Somebody comes to Alex or Giuseppe or somebody else in SRE and would say, hey, you know what, service X is going to go to boxes Y and Z. But we could have an automated tool that does that. No reason to have humans be a bottleneck there. And we could also decouple the service from the workloads, allowing us to run an arbitrary number of workloads and still only have only a few of them addressed by the service. That is, only a few of them receive actual traffic. We already have this via Pyball right now, via LVS. And we can do very nice things with LVS and Pyball. Things like saying, hey, you know what, workload X, instance X of your app can receive just a small percentage of the traffic that all the others are receiving, or we can go around and fully depool one. But all of these tools are SRE only. They are there, they were created, and they're there with the idea of helping SREs operate everything, not with the idea of helping the developer. And so developers don't really have access to those. They cannot really play with those. And another thing that would help us struggle problems away is building the deploy repo automatically. And yes, we will be calling it a Docker image from now on, because that's what we ended up with implementing. And use the Docker image as well for deployment, because we can do it locally. We can use, and we've actually demonstrated this, we can use the Docker image locally to develop stuff. So let's take one of those bullet points. Let's take the build deploy automatically, and let's talk about this, because this is the major work of a pipeline currently. So the pipeline is powered by Jenkins and Blubber. I'll be referring a lot to Blubber in the coming slides, in case you haven't heard about it before. But the entire idea of the deploy of the pipeline is that you upload a change, and tests are run. you get your reviews, you merge the change, you obtain the Docker image, deploy repo, the artifact, if you want to call it other names. You actually run integration tests. The pipeline can do that for you, and then you just deploy. And we can actually see that in practice, how it happens on the day-to-day. So live camera action. I always wanted to say that, by the way. This is a slide that contains a snapshot that I took today from Garrett. And we have a software there that is called Termbox. It's by the WMD team. And you can see that user Thomas Taro uploaded a change on July 9 on the Termbox repo. And then the pipeline bot goes around and gives some input, votes. It's actually a success. And right after that, there is even Jakob from WMD that also shows up. And there is the usual stuff that you all know about. But at some point, Jakob says +2, and then the pipeline bot goes around, merges. And the line that the entry that they expanded there, and it's marked in red, it's the new stuff. And you can see that the Wikimedia pipeline project there has said that, hey, you know what? We have that Docker registry /Wikimedia Termbox image. That's a Docker image that you can go around and pull. And here are the current tags for it. And you can see two tags. One is a snapshot base, 2019, July 9th, and the time, and plus the production stanza that we added there. That means that it passed tests. And there is also a git hash there, that 799 thing, which if you look at it carefully, you realize that it is the exact same string that is a git SHA of the commit that Thomas uploaded. That is viewable on the middle of the screen where, right under the author it says commit, and you can see the same exact string. So what the pipeline did there is that it built the image, and then it gave the image two different tags. It's the exact same image, the exact same version of the image, but you can refer to it by two different names. One is the timestamp thing, and the other one is the git SHA one thing. That allows you to implement two different deployment strategies with that, or release engineering strategies if you want with that. One is a fully timestamped based. You just know every point in time that you've deployed a specific timestamp based release to production. The other one allows you to do just Git deployments in the way that, you always know what kind of Git commit you have deployed, because there is a one-to-one correspondence between a Git commit and an image. So when you test a specific image, you are pretty sure that it's the exact same thing that it's going to end in production, and it's the exact same thing that you locally tested against, and of course the CI tested against, and all that. There is a third one that's not viewable there, a third approach that's not viewable there, but it's used by analytics team, and support for it exists. And if you want to do semantic versioning, it's pretty cool. If you push a Git change that has a tag, a Git tag, that tag will be used as is as well to be added to the resulting image. So if you go through that, you also have the option of doing semantic versioning via your Git tag releases. Andrew Yoda from the analytics team found it very useful. Pretty happy that he did, and I'm pretty happy that we added that functionality. It's just something that we need to document a little bit better, to be honest. Now, why did we actually call this a pipeline? If you go around and click on that red ellipsis is on top of the image build success button. If you actually click on it, you could go to something like this, where you can see why it's a pipeline, because it's steps one after the other that are being executed. And you can see that we have a checkout patch step and a build image step, and then there is a run image test step, and so on. And I've chosen there to just, expand the run test image step, but I could have expanded any other one. And you can just see that it goes around and does an NPM test at the end of the day, running the test for this specific thing, which is in TypeScript, and which is a JavaScript variant. So those steps in the coming versions, not right now, are going to be configurable. That's something that is happening slowly in the pipeline. And the entire idea is that you will be able to configure the pipeline to your needs, which might be different per software. So a lot of companies have been are going around and doing various deployment pipelines at the end of the day. Everybody's inventing a pipeline today. Why did we go around and do that? One thing is that when we started discussing this a couple of years ago, there was really nobody doing it seriously, aside from the very big players and the very big clouds, to which we cannot go for reasons not to be discussed here. The other reason was that nobody was really doing it, so we started doing it on our own. And one of the things that we met was that, you know what, Dockerfiles are actually really hard. This is a list of mistakes that anybody can make when they create Dockerfiles, and it's really easy to mess up. You can go around and do them. The usual is simple mistakes, which is using dependencies that are not pinned or frozen, as the terminology goes. And that can happen both for your internal dependencies, things like not freezing a specific Python package that you want to use, or a very specific node module. But you can also not go around and correctly pin things to specific versions, for example, of Node.js. We do have that currently. We have images pinning Node.js versions 10 or 6, and so on. Other mistakes that you can do is that you can have changes to your source code invalidating build caches or invalidating the various Docker optimizations, making everything take way longer and consume way more space. The usual mistakes that you can go around and see, and most of the Dockerfiles you can find in Stack Overflow, is that if you end up copy-pasting them, the software will end up running as root. And running as root in containers, in Docker images, Docker containers, or any kind of containers actually, is not as safe as some people will want you to be. There was, in fact, a couple of months ago, a vulnerability that was present in most container runtime engines that if the image was running as root, it was trivial to escape the image and arrive at the host. So that's one thing that should always be avoided, and it's easy to forget it. We forgot it, SRE forgot it in one of the images that they are internally maintaining. So anybody can make that mistake. There's also issues like ending up in really bloated images. They're using external services to do stuff, and paths are not standardized, which makes it a beautiful thing when you want to debug and you end up finding code in places where you did not expect that. So Blubber, which is an abstraction of Dockerfiles, were created. It's a declarative tool written in Golang. Dockerfile, by the way, has an imperative nature. You're at a relatively declarative stanza in YAML, and all it does is generate a Dockerfile for you. And it supports slipping down images using multi-stage Dockerfiles. That means that all of the dev dependencies that you might have installed during this process no longer is in the resulting image that you're going to publish. That means that the resulting image is going to be way smaller, which means faster deployment time. It also has policies for configuring a variety of things, like, for example, not allowing to use any kind of Docker registry that you do not want or you do not trust. It makes sure that source code files or directories, that means our source code files and directories in images, are not owned by root, but they're owned by a user. And the code is not executed by root as well. And I have a link there if you want to see more about Blubber, but let me show you, it's in Wikitech, but let me show you actually Blubber HelloWorld. And it's as simple as that. You can see just version, what the image is, and an entry point that says a hello world. But this measly 5 lines, when you pass them through Blubber, they're going to be transformed into this, which is quite a bit more. And what it actually does, it goes around and creates a Unix user, somebody that is going to be, and it's actually named somebody, by the way, that is going to be owning all of the code that is going to be installed. That is your own code, the deployer's code. And then there is a user that's called a run user that is going to be running the app as, because one of the key points about securing services is that you do not run the code in the same way that under the same user that it was deployed. Because if the application gets compromised by an attacker, if that held true, then they would be able to execute arbitrary code. You just added one more layer of protection around by separating the two users. And that's kind of a standard status quo in most of the applications that are being deployed. There are some exceptions like, Joomla, WordPress stuff where they want to be able to install plugins and all. And it's a security nightmare at times. So we took the decision to create this tool that generates, those Blubber Dockerfiles, but we also took other decisions during the pipeline process. And one of these was that we wanted everyone to be able to use our registry and our Docker images. So all of the images are available for anyone to use, and they are under dockerregistry.wikimedia.org. Don't go typing the URL in your browser. It's not going to give you back something because we don't yet have a nice web interface. We're working at it. But if you go around and use the various APIs of the Docker registry, you can and you will be able to pull images and test them and use them. But that's read-only. Nothing but the pipeline and CI can actually push images to that registry. And that's a conscious decision because we don't want anyone else to be able to push images there so that there is no abuse of those. And those images are always going to be based on base images provided internally. That is, base images that the SRE team will be taking care of. They will be upgrading them and making sure that they don't have any known vulnerabilities. This means they will also be based on Jessie, Stretch, Pastor, and other Debian versions as time goes on, as more are being released. And that also means that, yes, no Dockerhub images, nor any other registry images out there. And I'll expand more into that later on. And we are in the process of discussing about creating tooling to ensure as simple as possible upgrades for all of those images, because if you want to visualize a tree starting from those base images to all of the production images we'll be running, as you can understand, it can be a difficult thing to know which exact component is vulnerable to a security incident and be able to rebuild all of those images, all of the dependent images in order to protect against it. One of the most interesting decisions that we have taken up to now, and we're still discussing it every now and then, but up to now we don't tag Docker images as latest. As anyone that knows Docker around here will tell you that it's kind of standard to have the latest Docker image for any image. But truth be told, latest is kind of a mess. Latest doesn't actually mean latest. All it means is that somebody pushed an image without specifying a version. And just then, it's just the latest. I was added by default. That means that if you push a very specific version of an image, you tag it correctly with a version, latest is not going to be pointing at that. So it's badly named. And somebody needs to tag and push latest on purpose in order to update it, or forget to push correctly in order to update it. So that's kind of ambiguous and weird. And how do you do that in a pipeline? In case you can have race conditions. How do you go around and you know that it's version X and not version Y that is the one that warrants being called latest? For these and other reasons, even Kubernetes docs go around and very clearly spell it out and say avoid using it. It's very ambiguous, very difficult to know what it refers to. Very difficult to know that you actually upgraded because you no longer have something to tell you that, hey, you know what, you're running version X and not version Y. As already said, we will not be using Dockerhub or GCRIO or any other registry images. The actual reason will be talked later. I'll be talking about it later, but I'll just want to give you an idea. So there was this project that was released a couple of weeks ago, vulnerablecontainers.org. That's the official images in Dockerhub. And you can see the numbers there. And I can tell you that when I looked at it today to update the slides, the number was 17, but a couple of weeks ago it was 720 different vulnerabilities available through the Node.js image. You can see that Rails, Django, and Java have not been updated yet. So the entire thing is that, those images are maybe fine for local development and all, but they don't look like things you want to run in production. And we want to avoid having those kinds of issues. Add that to the fact that back in 2018-17, Dockerhub images were found with crypto miners in them. And this is starting to paint a rather not rosy picture, quite the contrary. But the main reason we do not want to have other registries around is that we want to be able to upgrade very easily and quickly and without having any kind of blockers whenever the next heartbleed, shell shock, ghost, whatever, you name it, whatever vulnerability shows up that somehow ends up meaning that any kind of, a small system can be compromised. Things like a libc vulnerability means that everything needs to be rebuilt and repackaged in a common Linux system. And if we have any kind of third party in that process, in that supply chain, it means that we are blocked on them, waiting to upload them. And if they're volunteers, by the way, most of the images in Dockerhub are maintained in reality by volunteers, well, we're kind of done for. We're blocked waiting for a very important security vulnerability to be addressed. So the only way we can maintain trust in our pipeline is only the Wikimedia community controls the entire supply chain of the images. So we talked about the image creation decisions that we took. But after you get the images, the ones that were created by the pipeline, how on earth do you deploy these things? How do you orchestrate them? And let me tell you a secret. Docker on its own, it might be okay for local development, but for orchestrating workloads, it can be painful. There were even some talks in previous KubeCons about how painful it can be if you don't have some kind of orchestrator around Docker, because it's an excellent workload executioner, but it's not really a good orchestrator. Networking is quite painful in Docker. It makes assumptions that you might not like, especially when you want to run many workloads in production. Understanding the global state of a workload, like, for example, how many instances do I have and what kind of version is running, it can be difficult to discern. Docker Swarm made recently some big improvements in that, but still it's kind of clunky. Metric loading needs to be implemented by you, and I mean really everything needs to be implemented. There is nothing there that will, aside from, tailing standard output, that can provide. Nothing can help you. You have to go around and implement everything. So there were voices years ago that were talking about adopting Docker. Back then, Technical Operations, which was the name of SRE back then, said, no, this is not happening because it would be a nightmare having this thing in production. And then Kubernetes came along. It was released in 2014, a couple of years after .cloud released Docker. And it's currently the de facto standard for orchestrating containers, container images, and container executions. And WMF back then, thanks to the efforts of the WMCF team, became a member of CNCF, of which now Kubernetes is a graduated project. And the SR team was lucky enough to obtain some knowledge around it. And after evaluating briefly some other tools like Messes and Nomad, we decided to go with what seemed like the standard, like in order to be able to take advantage of the community that will be built around it. And we decided to go with that. So what does it give us? I've already talked about the scheduler. Yes, it has a scheduler. And you go around and you size your workload. You might hear me in IRC channel saying, size up your pod. It is go out and find out how much CPU and memory does it require under stress and under normal operating circumstances. Decide how many instances of that you want in order to be able to serve the expected traffic for a specific service. You might be able to go around and give it hints like, hey, you know what, this specific workload needs GPUs, It needs to be spread across multiple nodes because we need high availability in case one of the nodes dies or other things like that. Or it needs to be run dedicated. With all of these are things that are supported. And you give via declarative inputs all of that to the scheduler, and it will do the best that it can to spread nicely the workload across multiple nodes. And it does a pretty good job at that, at least as far as we've witnessed up to now. There's rumors around and stories about edge cases where things can run not so nice and it can run amok and cause issues, but we haven't met any of those. So we're okay up to now. And one of the best things, and we actually run across this thanks to yours truly, is that it will reschedule workloads if a node fails. So if a node, for whatever reason, dies, the scheduler will realize this within a configurable time limit, currently 5 minutes if I remember correctly, and it will reschedule the workloads on other nodes. That means that no lost capacity for a service. It means that if something dies within 5 minutes, we can know, and that's of course assuming that the cluster is not under very heavy contention, the capacity of the service will be brought back to normal operating levels. What else, though, does Kubernetes gives us? It also provides us with the power to decouple the service from the workloads. And it does this in a very flexible tagging scheme. You can go around and provide a workload, a pod, as it's called in Kubernetes language, a set of arbitrary tags, and then you create a service, and you give the same arbitrary tags, and they are bound together, and then you can create other workloads. Like, for example, you can spawn X workloads and only have a number of them being serving production requests because of a tagging scheme. And that allows implementing canaries. You can go around and have a number of workloads having version X, and then another number of workloads having the next version Y, and then by careful calculation of the percentages between the two, you can go around and say, hey, you know what? A small percentage of traffic for this service is actually going through the new version. We'll leave it like that for, I don't know, 3 hours, 3 days, and after it's proven, we just upgrade everything to the new version, which is nice. The other thing that it does is that it monitors workload endpoints, the pulse failing ones. That's something that Piebald does as well. But the difference is that this is actually viewable by the developer on the API, whereas for Piebald, the live monitoring and live deploying is not viewable by anyone who doesn't have access to the logs, namely SREs. And that means that if a specific workload crumbles under the load of too many people are requesting access to it, it can be depulled until it's functional again. It doesn't receive production traffic, and then it can be repulled. This behavior can, of course, as you can realize, create some very nice domino effects of cases. We haven't yet met many of those, but it is something that can happen, and things that we can react to. We do have plans to be able to react more by adding more capacity, for example, to the service. And it implements by default, let me point that out, blue-green deployment. That means that you might have X workloads to start with. You will continue to have X workloads to start at the end of the deployment, but you upgrade them in batches, say 25%, which by the way is the default. That means that if you have 10 workloads, well, not 10 because it won't make my numbers easy, 20 workloads, 5 will be upgraded in each batch. So 5 new ones will be spawned, they will be health checked, traffic will start flowing into them, the 5 old ones will die, and then we go on to the next batch of 5. And if problems arise, it stops automatically, and it does allow you to roll back. Although rolling back is manual, it's not automatic. Stopping the upgrade is, however, automatic. And other things that it does is that it's actually declarative. And you might have heard that with Puppet before, the tool that SRE uses to manage configuration across the fleet, but Puppet in reality, so you go around in the Kubernetes and you define the version of the image that you want, your number of instances, policies, configurations, whatever, and it will make it happen. Assuming you haven't messed up what you asked of it, which is easy at times to mess it up because it's YAML. It's not the most beautiful format in the world, but it will make it happen at the end of the day. It will make its best. And that means you no longer have to go around and care about state transitions. What was my previous state? What is my next one? How is I'm going to do that? Tooling and all. As long as you have written your code well and you go around and you declare your new version, it's just going to happen. Now, someone might say, very rightly perhaps, that, hey, you know what? You vendor locked in yourselves. Kubernetes is a platform that is vendor locking us in, Google and all. But the truth is that a lot of the parts of the platform are pluggable. So, for example, the runtimes are pluggable. That means the container, the things that run containers are pluggable. There is now a standard called the Open Container Initiative. It exists for a couple of years, and we're not locked into Docker. Any OCI compliant container runtime engine will do. We do have Docker, that's why it's bolded there, but CRIO and Containerd do exist, and they can be used as well. And the Kubernetes networking paradigm is also pluggable. There is the standard called CNI, Container Network Interface, that anyone can implement. I've listed a couple of there that implement that. There are many, many more. In reality, it's a very open space for anyone that wants to create a public or a private cloud, and it allows you to have a selling point here. And that's where we actually had to do an evaluation because, with the container runtime engines that I talked about earlier, truth is Docker, when we took the decision, was the only viable solution. Now CRIO and Containerd are viable solutions as well, and we need to evaluate them. But as far as networking go, we did have a lot of possibilities back then. So we evaluated a lot of them, and we went with Calico. Project Calico is one of the CNI plugins. It's also used in OpenStack, but we chose it because it was very compatible with our current working setup, which means we had to do 0 changes. It avoided the complexity of overlay networks, which other things like Flannel, which is used in ToolForge, did. And it supported network policies, which was a feature that has been asked by our developers in the past. That is, they want to be able to know that, hey, you know what, a compromised service is not able to reach to all of production. That it's outgoing connections are going to be blocked right on that level, and they will not be allowed to be, running, I don't know, Nmap and scanning the entire production. And that's actually great. And we do have it working right now. We have to whitelist applications from talking to specific endpoints in production. And with all of those nice things and decisions, there also comes caveats. One of them is that when you abstract away problems, you have to create new ones, and you have to create new concepts. And there are many, many, many of those. I've listed some of them there, but the list goes on. And the rough reality is that you have 9 new concepts for workloads, 4 new concepts for services, 6 more for configuration, storage, and all. And it's not really all that great having to learn all the Kubernetes API by heart just to be deploying a Node.js application that does wiki text manipulation. And all of them are defined in YAML, many, many lines long each, and it can be kind of a messy to work with them. So we scarred the environment, the ecosystem back then, and there was a tool, but it looked like it's going to become the de facto solution. It was called Helm. It's still called Helm, and it's the equivalent of apt-get or DNF in the Kubernetes world. It's a package management tool that allows you to deploy applications. And it abstracts all that complexity that I talked about, all those new concepts away. It provides you with a simple CLI that you can go around and say, hey, you know what, I want to install MediaWiki, and I don't have to care about services and pods and deployments and staple and replica sets and all those things that I talked about earlier. And the de facto standard, there are others, but it looks like it's going to be the one that will have the majority part of the market for now. And the idea is that you go around, you create all those concepts, all those Kubernetes resources, and you just group them, make them a little bit more configurable, and deploy it. And that creates the concept of a Helm chart. which is called chart because the Kubernetes ecosystem is obsessed with sailing, may I say it. So the chart there does not refer to graphs or diagrams. It refers to actual charts that, helmsmen on ships actually, open up, and they are maps of where the various harbors and shallow and deep waters are and all. And, you use them to group and deploy the various Kubernetes resources. Those allows you, the templating part allows you to set various values. The most common one being the version of the app. That's the thing that actually gets changed a lot. And you can share this with the rest of the world, with the entirety of the community, and allow them to easily deploy their own versions, their own instances of your software. And you can, of course, use it again for local development as well. And we have our own, and we have two links there. The one is under releases.wikimedia.org. We can go around and see our charts. All of these are currently used. And we also have the Gary repo where you can go around and submit new charts or submit changes to charts. You see that the repo is under operations. The rough reality is it's just historical. We're not the gatekeeper there, although you can always tag me as a reviewer, so I can provide input on and feedback on the various changes that one is proposing, as well as the rest of the SRE team. We're not gatekeeping there. You can merge it if you want. At the end of the day, the chart is up to you, or whoever you are as a developer. But again, having to create a chart for the very first time can be a little bit daunting. So we created some scaffolding for that. And the use of the scaffolding is, just git clone that repo and run that script to create new service.sh. And it's going to ask you a couple of questions, like the name of your service, how's the image going to be named, and that's about it. And then you have your chart. You can optionally edit it, change stuff. I urge you to do it because some of the stuff cannot really be that simple things. There are readmes in there and notes that are going to be displayed in the face of the deployer. It's nice to provide them something more than the generic stuff that we are able to provide in the scaffolding. But you can submit it for review and can be merged and a chart created and published. And that way you can go around and deploy in our own deployment pipeline. And this is in reality used by the pipeline. As I mentioned, aside from the various unit tests that are being run by the pipeline, the NPM testing that we saw when I was showing the Turnbox NPM tests earlier, there is also integration tests that you can run. And that's how integration tests are run by the pipeline. Those are the Helm chart tests. And they are part of the Helm chart. You can go around in many of the charts that we have. All of them have tests. Feel free to look at them. And the thing that we have currently standardized on is that we use this tool that's called Service Checker that the SRE team has written internally. And it defines probes. It relies on an open API, Swagger endpoint that defines the various endpoints and probes that you can run against those endpoints in order to know that the software is operating nominally. And the exact same thing is also running in production. So at the end of the day, our integration tests and our actual live production tests are converging, and they're going to be more or less not really distinguishable implementation-wise. You can easily document tests, customize existing ones, and use them. So with all of that, let me give you a very quick runabout about what is the current status and what is the roadmap. We currently have 9 services in the pipeline. I named them there. They're Blubber, Tidoid, and all. Many thanks to all of the deployers that have gone through the process of the pipeline in order to have their services deployed by that. Thank you very much. And I'm hoping that it's proving to be a better solution than the previous one. Some of the ones to be added soon, things like REST Router, which is a split off part from REST-based, change from CB job queue and Wikifeed, which is a split off part from the mobile content service, are to be added in the next quarter. And in our roadmap, which is kind of not sure when it's going to happen because the pipeline was not chosen as in the annual plan. We want to document it better. We want to help create a local development environment that already kind of exists based on Minikube, where there's still some work to be done on that. Encouraging household the various other service owners to migrate services to the pipeline. That includes MediaWiki, although we are not sure when we will be able to start that part of the work. But at the end of the next fiscal year, it should partially have happened. At least I'm hoping to. We need to add tooling to automatically respond to increased and decreased demand. That is, be able to automatically spawn more instances of whatever app is running in order to increase capacity, and do the inverse when increased demand recedes. So to get back the capacity from the service. Be able to create highly available endpoints for the apps, for the various developers, then in order to be able to route their applications more easily and with less SRE intervention. That's something that we need to work more on. And we also want to add in the various services TLS demarcation, that is not just termination, which we already have via Nginx. We also want to have services reaching out to the world via TLS without having to implement internally in any kind of way TLS. We want to abstract TLS away from the various services and service owners, because cryptography and TLS can be a hard thing to do correctly. And we want to add, of course, telemetry, in order to have things like latency, better latency metrics, and things like that. With that, thank you very much. And I'm hoping that you enjoy the presentation. And please, we have time for questions.
Thanks, Alex. Go ahead, Andrew.
Sorry, I was going to ask, is MediaWiki on the roadmap?
As I said, the annual plan did not choose pipeline to be added in it, so it's not entirely clear. It's the last of the services that will be migrated. At the end of the day, it is on the roadmap, but I cannot tell you when it's going to happen.
Gina, that's a local dev version of MediaWiki in Kubernetes?
Yeah.
Cool. The TLS demarcation you're talking about, I'm not sure I fully understood that. That means that when apps have to make remote connections to other services, somehow...
Let me give you an example.
Yeah.
Let me give you an example. So let's assume that some application that runs in the cluster of Kubernetes, let's say ChangeProp, needs to, for some reason, talk to EventGate, whatever. The idea would be that ChangeProp knows nothing about TLS. It talks locally to a proxy, to an HTTP proxy, that knows to initiate a TLS connection to a corresponding proxy that resides in front of EventGate and terminates the TLS. The idea is that everything will be encrypted as long as it's on the wire, and the decryption will be happening right next to the application. And not just the encryption, sorry, the decryption and the encryption as well. So all of this will mean that nothing TLS-wise will be visible to the applications. They won't have to import libSSL or tools that get them to expose ciphers to the code and things like that. Does this answer your question?
So it just seems like usually that stuff to initiate connections is relatively easy because it's built into, say, like some HTTP library. But you're just saying that the differences between all the different TLS libraries out there might have security implications, and it's better just to abstract that stuff away so you don't have to worry about it.
Exactly, and I can give you a very nice example about that. So back in 2000 and I think it was 15, Node.js decided to embed CA certificates in their own code repo, and it's part of a TLS. Let's call it, it's a detailed implementation where actually all those TLS certificates go from, how do you update them and all. And at some point, it turns out that they were having certificates that were expired, and they were no longer in use. The actual clients that we wanted to talk to had switched to using different CA certificates, different CAs that were not part of Node.js. So that was implementation detail that gave a lot of pain to the language engineering team back then, because they were trying to figure out what on earth was going on. What are those very cryptic encryption errors that we're getting? What happened here? And all of that was just because Node.js decided to not do things very nicely on the TLS level. And that goes on for all libraries that, they take decisions at various levels about TLS and SSL and all. Yeah, it's difficult to keep up with TLS these days. It advances way faster than it used to.
Would that, for internal services talking to services, if they don't have, right now, I guess, like if we wanted to post an HTTPS something to Eventkate, we would go through the Nginx termination, because the app itself doesn't have any of that in it. But this would just sort of abstract that so that all Kubernetes pods would just expose some HTTPS endpoint. Also, is that right?
Yeah, that's more or less. Now, if you want to imagine the implementation of it, it's more like an Nginx that actually does the termination, and an Nginx that does an initiation. That's one way to implement that.
But each Nginx server that's doing the termination is deployed alongside with each app.
Yes.
It's separate. Okay, cool.
It's called a sidecar. The terminology is a container sidecar.
Thank you.
So Scott had a question in the chat.
How is data? Let me actually read it for everyone. This is for the people as well that might be looking at the stream. This is maybe a naive question, but how is data as opposed to code handling this process? For example, if we wanted to spin up a local dev instance with a representative subset of articles, cleaned of sensitive info for testing. The pipeline has no provision for that currently. And while some parts of it have been discussed in a staging cluster, there is itself for
the data that you need for testing, or do you need something really recent?
I guess so, but it would be up to the developer, wouldn't it?
Okay, we have 2 minutes left. Any last questions? Scott, are you talking? You're muted. Scott, we can't hear you if you're talking. Okay, I guess not. There are no other questions on IRC.
There is one from Automata. It says, if a pod keeps failing to respawn, KDS will stop trying. Is there a respawn limit in order to prevent a domino effect? Yes, there is. If a pod keeps on failing, eventually the Kubernetes kubelet will put it in a what it calls crash loop back off state. The back off stands out for backing off exponentially. It will not try to restart it for some time, and then some even more time, and at every single failure of that, it's going to provide even more time between the various retries. So yes, no domino effect in case something keeps on failing very, very quickly.
Okay, we have 1 minute left.
I might try to answer Scott's continuation of that question there. You might, for a development environment specifically, you might be able to do something with your Blubber files to build the development environment images differently than you would the production ones. such that they would actually pull down whatever test data you might need to run in your development environment. And those would be actually different images than the ones that would be used in deployment production.
Yeah, also as a response to that, this is something that falls under the local dev project, which is still in early days. So this is something that's sort of being kicked around, but we don't have any real plans for it. It's not officially on the roadmap, but it is a nice to have thing. Some repos to check out are the local charts repo that has the current very alpha local development environment. So yeah, I'm sure we'd appreciate folks kicking that around a bit and giving suggestions for feedback.
All right. Thanks, everyone. Thanks, Alex, for the presentation. That's a lot of information. I'm still trying to digest it. It's looking forward to using it in our new services too. And thanks to everyone for their questions. And thanks, Brendan, for setting this up.
Thank you.
Bye.
Thanks, everyone, as well.